Hello, teacher. We'll be presenting our parking management system, and we have four members. My name is Monika. My teammate Chheng Kimter, Phengroth, and Poch. Can we move to the next slide, please? So here is our table of content, and here's what we will cover. First, an introduction to our project, including our objective and problem we're solving. And second, the data, structures and algorithm behind the system. Third, our file I/O and overall system design. And finally, a live demo of the application. Um, okay, so for our project objective, let's start with for this project, we set out to implement core data structure completely from scratch, no built-in libraries, including linked lists, stack, queues, and sorting algorithm. We also wanted to compare the time and space complexity across these structures, and most importantly, build a fully functional system that mirrors how a real parking facility would actually operate. So for the problem statement, now the problem that we are addressing, parking facilities, especially in busy areas like school, campus, or office building, often lack an efficient way to track vehicle entry, exit, and available spot in real time. Staff typically rely on manual logbooks or rough head count, which are slow and error prone. This makes it difficult to know exactly how many spots are left for cars versus motorbikes, or how long a vehicle has actually been parked, leading to confusion during peak hours and inefficient use of limited space. Next slide, please. So for our solution, it's a console-based parking management system that um, digitizes the entire process. It tracks vehicle check-in and check-out using a doubly linked list, manages separate waiting lines for cars and motorbikes using queues, and logs recent parking action using a stack. We also built a sorting feature so staff can view vehicles by arrival time, parking duration, or status. And all of this data is saved through file I/O, so records persist even after the program closes. Something a manual logbook simply can't guarantee. So for the next part, I will give it to my teammate.
And now let us start with the data structure. A data structure we have implement uh, a few data structure into our mini project. They are which are linked list, hash map, stack, and queue. And so the first one is linked list. Linked list here is controlling the vehicle, the capacity, the the available the zone, and we can delete it from the CSV and insert it from the CSV. And we use the linked list to store the vehicle information. And then we can make the linked list to connect it with stack and queue later on. And about the hash map is used to link to the ticket ID that specific vehicle to the vehicle plate number. It's allowed to search for vehicle based on the ticket ID or plate number. So when the user check out, we use HashMap. Why we use HashMap? We use HashMap here to verify the ticket. First, it's compare the ticket and the plate number. It's if it is matched, and then it will go search in the table, and then it will show it. And next one is stack. For stack is we use stack is to undo the previous action. That means when the admin get the ticket, checkout or waiting line, and then the admin mistype or wrote type the plate number wrong, the ID wrong, then we gonna then we have the undo action. Why? It will undo it. Let's say if the admin get the ticket, and then it mistype the plate number. But once the admin undo the action, it will remove the vehicle from the parking lot. And then say it's checkout, the admin accidentally removed the wrong plate number. When you click undo, it will undo it. That action, it will add the vehicle back to the parking zone. And last one for queue in the data structure, the queue here is for waiting line. Let's say queue is When the parking zone, the parking lot is full, we the when the parking lot is full, and there's a people that are waiting outside, and that this where queue come in handy. We will include the we will include the first vehicle that come into the waiting line, and when there's people checking out, the queue will include the first car that include to the waiting line, and that's how it works. And this one is the algorithm. The algorithm here is we use sorting. The sorting is the sort vehicle record by entry time, duration, or status. We can sort it for three, and we flip the record in half rapidly, then merge back in order. And for time complexity, it's O and log n. The space complexity is O and lastly, we use the sorting here is for the stable performance regardless of the input orders. And next, I will pass it to Sathya.
So after knowing about data structures and algorithms, so now we gonna find out how we store the data. So we store the data using file management system, file IO, CSV. So here when you get your ticket based on the vehicle type, car or model, it will the data of the plate number, ticket, and vehicle type will be saved in two separate files based on the vehicle type. So if it's a car, it will save into cost.csv, and if it's a motorbike, it will save into motorbike.csv. Next. And then we have three more files to save the history logs. So for history.csv, it store the status of the vehicle when those vehicle left the parking place so that the data won't be lost, and we could sort the vehicle based on status, whether it's still parking or it's already left. So if the status is still parking, it will store in sort meta.csv, and for the revenue.csv, we count the amount of vehicle based on the vehicle types and then calculate the cost of the ticket. Yes, that's all for my part. And after knowing about file IO, CSV, we will find out about system design. So when we run our program, there will be a menu that lists 9 options. So the first one is you get the ticket, and the second option is checking out. Third option, undo the previous action. Fourth is search for the record info based on ticket ID or plate number. 5 is check the vehicle zone availability. So there's two zones, one is for car and another one is for motorbike. And the last and 6 is sort based on the vehicle types, and we could sort for the entry time, for the duration, and for the status. And we also could calculate the total revenue, and then we could exit and clear the page. So if we get your ticket, you will if so when you get your ticket, you will ask to input plate number, vehicle type, and then you will get your ticket if the parking place or parking zone is available. If not, you will ask to go to the waiting list. And second option, when you check out, so when you check out, you will be asked, are you sure you want to check out? And then when you press yes, you will ask to input your ticket ID and plate number. And then when you check out, your vehicle information will be deleted from the car CSV or motorbike CSV. And for next, we have undo. So when you get your ticket and if you type your plate number wrong, you could immediately undo it and retype it. You will the last line of the information that you fill in will be deleted from CSV and you could input again. And for and then everything will be updated to the CSV, and next time you run the program, you will be all the data in the CSV will be load, and it will read those data and proceed the same way. Yeah, that's all. Hi, Phengroth.
Welcome everyone to our project demo. Here I am your presenter Chheng and I will be the one to go through our program for you guys. So first of all, when you load in, it says welcome to parking management system, and then we have 9 options, which is get your ticket, checking out, undo previous action, search for vehicle information, check vertical zone availability, soft menu, check revenue, clear page, and lastly is the quick. So let's go with number 1 first to get the ticket. When you choose option 1, you will have to enter the vehicle type, which we have the car and motor. So let's try the car first. And then the plate number. Here it will say ticket print, and this is our detail. Now let's go to the car CSV. You will see that the one that we just entered here is written to our CSV file. Now let's try the number 1 again, but this time we go for moto and then plate number. Here we say ticket print, and here is our ticket information. Now let's check motorbike, and we can see here is the newly updated ticket. Now let's continue our program to check out number 2, which is the checking out function. So it will verify if you want to check out or not. And then here we have to enter the ticket ID. Let's start with the motorbike one. I'll start with this ticket here. I will enter TB7. And then the plate number of the vehicle is 1W1234. Here it says checkout successful and history is updated, and you can see that ticket is now gone from our CSV into the history CSV instead. And here is the newly left vehicle here. Yep, and then let's try again, but this time I will try to get an error for you guys. For example, checking out for the car, I will prove the error. Let's choose this ticket number here, TC12. And then for the plate number, I'll enter something else that does not match the ticket here, the plate number in the ticket. So it will say invalid ticket ID or plate number. Okay, now let's go to number 3, which is undo previous action. The undo here is the checkout of our motorbike. Yeah, this one is the one that we check out up here, 1W1234, and now it is back into the motorbike, 1W1234. Okay, so let's go for number 4, which is the search for vehicle information. So this here, you can either search by plate or ticket. If you search the plate, it will return to you the ticket ID, but if you search by the ticket ID, it will return to you the plate number instead. Now let's try to search by plate number. Let's search for the plate 1W1234, and then it will show you the ticket number is TB7, which match the TB7 up here. Okay, now let's try to search for the vehicle instead, but now we try to get an error output instead. Let's go with ticket search, and I click TC here and at 19. So what if I search TC20? It says ticket not found. Alright, so moving on is the check vehicle zone availability. The zone here is show car currently have 10 car park, and that's the maximum already. And the motor zone is 13, but the maximum is all over the way to 200. So this means that you cannot check in as a car anymore. you cannot get more tickets. So what happens if you try to check it in for a car? Let's go for number 1, car, plate. It will say you're in the waiting line, and then history is updated. Now let's check car. You see this does not update anything at all until this one you have to view the wait line or not. Click yes, one wait line is in here, and then press any key to continue. Now let's try to check out the car to see what happened to the waiting line. Now I will check out the latest one here, TC 19 2T8888, and then it will say it has left the parking lot, and the newly added in queue earlier, this one was in queue, right? But then now it's already into the parking lot, which put it into the car.csv. Moving on to option 6. The sort menu here, you can view all type, or you want to view car only or motorbikes only. I'll go with number 1 first. And then you have the short option for entry time, duration, or the parking status. I'll go with the entry time for now. And here you could see all the entry time, 6 minutes, 7, 10. Yep, and then there's 0, which the car that we just newly add into our parking lot. And then now let's check by the sorting again, all type, but this time we pick number 2, sort by the duration. Here the duration will store up to 12 hours down to 0 minutes. Now let's sort again, and this time we go with the third option, parking status. Oh, that's a lot of the parking status here. Show from parking until the left. You see the bottom here is all left. Yep. So now let's go to check revenue option. Now it will say that the car parked from day 1 is 20 car in total, the motor is 29 total, and the money here is basically 20 times with 4,000 real per car, so the total is 80,000 real. As for the motor, it is 2,000 real per motorbike, so this is the total revenue for our motors, and then the total revenue down here is the combination of car and motor plus together. Yep, and then lastly is the clear page. It's basically clear our terminal like this, and then 9 is quit. So this is the end of our demo now. Thank you for paying attention from the start to the end.
ご覧いただきありがとうございます。